So we spent some time going over deductive argument forms. I also want to talk a little bit about inductive argument forms. Remember that an inductive argument is an argument of such a form that the speaker doesn't even intend to use the premises to guarantee that the conclusion is true. Even if the premises are true, the conclusion should be supported, but there's no intent by the author of the argument to show that the conclusion must follow if the premises are true. And just like with deductive argument forms, it's worthwhile to think a little bit about how some of these inductive arguments work. These are also in the Learning Logic tutorial, and you will be asked about them in the homework. So you do have other sources, but I thought a quick video would benefit at least some of you who wanted a little bit more material on this. So the first of these inductive argument forms is a prediction. And this should be pretty clear, right? If you want to make a prediction about what will happen in the future, almost never is it the case that your premises are guaranteed to make your conclusion true as long as your premises are true. We see predictions about the weather. Every other time there's been a weather front like this, the next day it has rained. There's a weather front like this, therefore it will probably rain. Well, again, I have probably in there. And that's all that inductive arguments are meant to do, is to make conclusions probable, unlike deductive arguments, which are meant to make them certain. Another inductive argument form is an argument from analogy. You know what an analogy is. It's when two things are compared. The two things aren't exactly alike, but they have enough in common that I can infer something I didn't know about the second case that I was describing. So an argument from analogy would be something like, the Indian Ocean is very warm and tropical and full of colorful fish. And so the oceans around Australia, because they are also tropical and warm, are probably full of colorful fish. Again, there's the probably of the conclusion. An analogy doesn't guarantee that two things that are similar in some way will also be similar in a third way, but it's one way that probabilistic arguing, that is inferential arguing based on induction, is done. It's an argument form to be aware of. Next are generalizations. We'll talk about generalizations quite a bit later on as well, but right now we just want to be aware of the argument form. A generalization is when you have a certain number of cases of a certain phenomenon, and you try to use those cases or that case to infer to a population or a group or a type as a whole, right? We're familiar with bad types of generalizations. Someone says, well, I met people like this and they were also like this, therefore everyone who's like that is also like this. But sometimes generalizations are a worthwhile thing to do. Sometimes generalizations are more scientifically and mathematically grounded, and they're also useful. If we say something like 70% of Republicans want to see Trump get reelected, it's not possible that the people who are doing the census have actually interviewed literally every Republican, but they've interviewed a representative sample and they've made an inference about the general population. That's a worthwhile thing to do as long as you realize it's an inductive and not a deductive argument. It's also an important example to show that just because an argument uses mathematics, it doesn't necessarily mean it's always a deductive argument. If the mathematics is there where it's more dealing with probability or statistics, the inferential statistics, then we're just trying to claim what will happen based on mathematical facts about what we've observed. That's going to be an inductive argument even though math is involved. Next is arguments from authority. An argument from authority is just an argument that says, well, this person, who I'm taking as an expert, says that X is true. It's taking someone's word for it, for a probabilistic way of getting to a conclusion, and not actually a deductive way. Even if it is true that my doctor said I have hypertension, the fact that my doctor said it, if that's the premise, is no guarantee that I actually have it. It's a good reason to think that I do, but it doesn't follow from asserting some authority's claim that the conclusion is necessarily true, only gives probabilistic confirmation. Another thing Hurley talks about is arguments based on signs, and he has especially in mind here visual signs. If you get some water from the water fountain and that water is brown, you probably shouldn't drink it because there's a good chance it's unhealthy. But if that water is brown just as the result of high healthy mineral content, then it could turn out that using that water, at least in small amounts, could actually be beneficial for you. So oftentimes we point to certain signs that do suggest certain conclusions. It's a fine way to argue, but it's only an inductive argument because it's just evidence that makes a claim more likely at its best, and I'm not attempting to guarantee that the conclusion in fact follows. Now, causal inference is another type of inductive argument where my conclusions are not certain based on my premises. Now, this could probably overlap, and Hurley admits this, with something like arguments from signs. So hopefully the examples he gives us in the homework will be clear enough that we can differentiate these. But a causal argument is always an argument that relies on the process of cause and effect, which in its strongest form is a scientific kind of inference, but isn't necessarily. So if I say something like, the grass is wet, therefore the sprinklers must have been on to have caused the grass to be wet, that's an argument from some effect that I'm observing back to a cause. If on the other hand I say, I hear the sprinklers turning on, therefore it's about to get wet, that's an argument from cause to its effect. The sprinklers being on is a cause of the wet grass. So hopefully this review of the types of inductive arguments will give you a sense of ways in which you can identify inductive arguments. And all of these forms will be important when we talk about ways in which inductive arguments are made correctly or incorrectly, because not all inductive arguments are good. Even in the examples I gave, hopefully you can see that there are limitations to the degree to which these kinds of arguments can give us good reason for making a conclusion.